Nice big audience. So it'll be a quick talk. We'll run through a few, quick bunch of slides, and we'll see what we did. Right. There's a QR code right there in case you want to follow the presentation on the phones because you can't see whatever text is there. So I'm Ashwin. I'm an old school system and network admin. I come from the time before the term DevOps was coined. I'm in love with the black and white screen, so this slide deck took me like 4 days to make. I love the cloud. I love scaling tech companies. Zoomcar is probably my 5th or 6th company that I've helped scale. IoT is something that I spend a lot of time on these days, and I run my own mail and DNS servers, just to let you know. Let's talk about Zoomcar, right? It's India's first and largest app-based self-drive car rental company. We started out in 2013, and we're going really strong with cars and scooters. We have e-scooters, unlike what are the competitors? You've got I forget the name. There are a bunch of competitors who have scooters. DriveZ, for example, these are e-scooters, battery operated. We had cycles, which has been parked for a bit now. We'll be relaunching in a while. We're 100% AWS. Right? We don't have data outside the AWS at all. There's some more data that I can throw at you. We are operational in 40 cities. We have 3 million users on the platform. We do more than 4,000 rides per day. We cover 5 lakh kilometers every calendar day on an average. We have 10,000 cars. That's something that we already know. All cars are connected. There is no manually operated vehicle. All cars are IoT capable. We ingest 500 million IoT events from these cars every day. We have a data lake for analysis and reporting which is over a terabyte in size. And that's just cars. We do scooters as well. Now, I'm going to keep this talk purely about cars. We'll do scooters later. So how do we do this? Very simple. We sat down, we burnt ourselves. We burnt our families, we burnt our friends, we burnt our laptops. This is traditional DevOps behavior, right? You try to get things going, things don't go, you push till you burn yourself. This is how it goes. Why did that happen? Because we were in a cheap data center. Now, what did this data center cost us? In addition to being cheap, we had our highest uptime hovered around 70%. 70% uptime for a cloud capable company is basically as good as running it off your laptop, right? We had no network operations support. So 1 year into the contract with the data center, we realized they didn't have the second backup internet line. If the primary internet line went down, we were all sitting ducks. And remember, I said the cars are connected, but if the internet is down at the data center, who are they connecting to? Noisy neighbor problems. This is a beautiful story. Every day at 4 a.m. in the morning, Zoomcar would stop working. But 2 years back, if you have used Zoomcar, you couldn't pick up a car at 4, you couldn't drop off a car at 4. It was because there was a cron job that one of our neighbors was running, which basically took down our rack. Simple. Yeah, we started laughing, but then it got frustrating very soon. Right? Now, a traditional data center doesn't have the flexibility with networking. You get a box, you get a bunch of VMs, and you get a wire. That's it. So your hands are tied down on architectural decisions, design decisions, infrastructure decisions, and the DevOps guys are basically the most hated people on the floor because we never got any sleep, we never got a life, we couldn't go back home. You go back home, you're on call, you come to office, you're on call. So the reason was because we had to maintain our own systems and we also had to maintain our infra, which we had actually paid for, right? So we said enough is enough. We were starting off with a product called Zap Subscribe, where you pay for a car, you get to own the car, and you use it whenever you want. It's basically subscribing for a car instead of just renting a car, right? The car is in front of your gate for the next 18 months. So Zap Subscribe started off as an experiment, but it took off very, very quick. So we knew that we were going to go hit scales that this data center was just not capable of. We either had to shut down the product or we had to move. So we said, let's bring on the experts. Now let's actually pay money to do stuff, right? And then we moved to AWS. This was our plan. We had a 1-month migration plan. It took us 2 days to create about 130 instances that we set up on production. It took us 3 days to migrate about 1 terabyte of data, or rather back then it was about 700 GB of data. We took a 4-hour downtime window between 12 and 4 where we actually lost a lot of sleep and money, and then we were on AWS. It took us a sweet 1 night to convert from traditional DC to 100% AWS out of Mumbai. We operate exclusively in AP South 1 with a disaster recovery location, which I will not talk about. And this is what we've done post the upgrade, right? We have CloudFront delivering our websites. We have a 1.2 seconds time to first paint. Has anyone heard the time to first paint metric? UX, UI people would have heard it. It's basically when DOM ready event is fired by your browser, right? That means I am ready to now draw, anything on the screen that you ask your script to draw. It went down from 8 seconds to 1.2 seconds. My API cluster went from 2 seconds average response time to 150 ms, right? Because we were in Mumbai and EKS became GA, we said let's start using EKS, right? So a few of our services were directly moved to EKS and we got a direct 30% cost savings over a traditional DC, which is usually sold as a cheaper alternative in terms of cost to AWS. We have a multi-AZ RDS, so we basically said, you know what, RDS database DBA guys, you guys can go home. AWS support will handle it. Read replica slaves are something that we spin up on demand. If there's an analytics payload that's going to run for a particular reason, it spins up, syncs, delivers its data, spins down. We use AWS Glue, we use Athena, and we use Redshift for our data lakes. This does more data crunching than I've ever seen in my little bit of tech career that I've been in. Our average scale has gone up by 40x. And we ran a love you back sale sometime June, July, where we did 100% off discount sale, where we saw a peak load of 200x. We burnt a month's worth of AWS expense in one evening, but our response time stayed at 150 ms. That is basically what the cloud has got us. We use Elasticache, straight up, right? Memcache and Redis, managed by AWS. We use Kafka. We are currently using self-managed Kafka, but we're slowly moving to Amazon message streams as well. And because AWS lets us scale, and the scale is actually considered infinite, this is our new mantra. Data is the new fuel. We have more data that we can now ingest. We have more data that we can now ask our producers to give us, because we can consume that much more. And what do we use it for? We use it for business intelligence. We use it for user behavior capturing. How is a user using Zoomcar? The app, the car, the website. We know what a user is doing on our systems. Quicker identification of UX drop-off points. So if you go to the Zoomcar website, or you open up the Zoomcar app on Android or iPhone, and before you make a booking and make a payment, you move away from the app, we know you've done that. And we know how to reach you back and try to coerce you into making a booking. Typical marketing strategy. This has enabled us. Demand forecasting. So Mysore Dashera happened last week. We knew what the demand was going to be, so we had cars stationed at the Mysore airport and the Bangalore airport. People had cars. We didn't have booking drop-offs. We have this information, we have this information, we have point 3 where we now forecast demand. And we have predictive maintenance. Because the cars can give us much more information that we can consume, we know when the car is going to fail. So the car won't fail in your hands. If the car looks like it's going to fail and it increases in the probability that it will fail, the car is immediately removed from the listing and brought to the attention of the fleet personnel who pick it up for servicing. So this has also given us cost savings, because we know that we can fix the clutch on the car before it actually breaks, right? Things like that. Data analytics, this is the meat of what we do. Every data point that we can think of, if we want, wake up in the night and say, what, can we get this data? We can do it. As long as there is a provider for that data, we can capture it. Our cars alone provide 500 million data points per day. That is an insane number because all that data is crunched live. So analytics on the cars is about 2 minutes from when the data has hit our systems. Customer churn. Based on customer behavior that we saw on the previous slide, we know if a customer will come back to our platform or not. Has he had a good experience? Has he had a bad experience? Can we figure that out? Fraud detection. Will you take a car and return it, or are you trying to steal parts? We can do that. We know that if a car is stolen, we can still recover it. Driver score. And this is something that went out into production, I think, a couple of weeks back, where we monitor how hard you clutch, how hard you brake, how hard you press on the accelerator, how quickly you change your gears, and that gives a cumulative score based on which you are rated as a good driver or a bad driver. A quick piece of information. So this is something that came out of our data as well, where greater than 50% of Zoomcar's customers have driven their first car in Zoomcar. So they got their license and 2 days later they booked a Zoomcar. Right? So that is cost we are bearing. And the driver score is sort of to help alleviate that or offset that a little bit. If a driver is known to be a bad driver, then I can give him a car that's already beaten up. I don't need to give him a brand new car. Right? I can think that. And that is how we connected 10,000 cars to the cloud. Very quick presentation. I think I've taken 9 minutes. But there's more. There's no point in me telling you, what, this is what we did. What is your takeaway from this? What I want to talk about is how would you do it? How would you connect the next 1 million devices to the cloud? This is what I want to be your takeaway from this remaining 15 minutes that I have. Now, building Zoomcar and building 2 other IoT companies and scaling them, this is my biggest learning. Bad decisions in architecture bite you real hard. Right? I know a company which basically was absolute make in India. They set the MySQL time zone to be Asia Kolkata. Now they want to go global. Work with it. Right? Be prepared to change at the earliest. The smaller you are, the quicker you can change. And that is a very important point. Managed services exist for a reason. If there is a managed service, it will be costly because there's someone else maintaining it for you. What you spend in managed services cost, or what the delta you spend in managed services, is far less than the engineering spend that you have in building capability and paying for the engineering time if you were to run your own resources of equivalent scale and reliability. Right? So, to connect the next 1 million devices, this is where I would start if I'm starting from ground zero. If I want to build an IoT platform and I want to build it right, this is where I'd start. So what are the key components in an IoT platform? You have something called ingestion, you have something called persistence, and you have something called analysis. These are the 3 tasks any IoT system is designed to do, and this is all that it has to do. Ingestion is where you take a message from the message producer, which could be hardware, software, person, whatever, and you consume the message, you receive the message. Second bit is persistence, where you save the message so that you can take action on it. And the third bit is analysis, where you look at a bunch of messages and basically derive learning out of it. Right? So, what are the bits in AWS that you'll have to be worried about? You have applications, you have devices, so you need to know how to manage those devices. You have messages, so you need to know how to manage those messages. You have storage, you need to know how to manage that storage. You have data processing, you have notifications, and you have analytics. Now, what does AWS do in this window? Applications. AWS IoT SDK, you've got it in JavaScript, you've got it in Python, you've got it in, I don't know, a bunch of other languages. You have edge computing with Greengrass. Has anyone here tried Greengrass? Has anyone worked with it? It is amazing to the extent where you get scared. You can get two Raspberry Pis talking to each other, figure out what data to send, and then one of these guys sends it back. You can build a system that's so simple but it's just unbelievable. Device management, AWS IoT Hub and device shadows. Device shadows are something that is not new, but AWS made it mandatory as part of their platform, where every device exists as a software copy, as a virtual entity on AWS. So it's a one-to-one mapping where if the device comes back online later, it can send data to that shadow and the shadow will push it back into the AWS Cloud. This is very important. In a scenario like Zoomcar, I leave Bangalore, I don't have signal. In any direction you go, you don't have signal. For the next half an hour, the device is collecting about 1.5 to 2 GB of data that it needs to send out. A shadow is what will help me do it. Message management, IoT message queue, IoT rules engine. Right, I will talk about these two in a bit. Message queue is a standard MQTT. MQTT is sort of the de facto protocol when it comes to IoT. It's a simple protocol, it works on TCP, it just does its job well. IoT rules engine plays on top of the message queue. What it does is it tries to take the message, apply a rule on it, and send it to a specific route. It's basically a router. It's called a rules engine, but in reality it works as a router. Storage. You have your standard RDS, you can do DynamoDB as well. DynamoDB is actually faster than RDS in many aspects as far as message storage is concerned, because you're storing it as a key value pair instead of a record. Data processing, this is the fastest you can get. Lambda. Spin it up, have the message persisted, the rules engine can trigger a Lambda whenever you however you configure it. It picks up a message. Once a message is seen, it knows what rule to apply, and as a part of applying that rule, it can call a Lambda. Now, can you call someone else after you've processed the message? SQS, SNS, they come and play. Analytics, you have EMR, you have Kinesis, and you have Redshift. EMR is good for bulk processing. If you've got data that's spanned the past few months, you use EMR. You want to do live data stream processing, you've got Kinesis. Redshift is where basically you store and do a ETL pipeline of it, right? Now, why am I selling you AWS IoT as a person who runs an IoT company but doesn't use AWS IoT? It's rock solid. The ecosystem is completely proven. There's no gotchas here. The only thing that you have to realize as far as AWS is concerned is that service available as a generally accepted release in your region of choice? That is the only question you ask with AWS. Is it GA? Infinite scale. And this I saw as far as EKS is concerned. We went to about 80 nodes and about 8,000, 9,000 pods on our system when we scaled. Insanely small time to market. I think Madhu already spoke about it. Programmability. Greengrass is the best that I have seen, having built a solution which worked very similar to Greengrass earlier. To have edge IoT capabilities is just brilliant. Insights. The kind of data gleaning that you can do with regards to the analytics pipelines on either Kinesis or EMR is just brilliant. Smooth learning curve. There's a lot that you already know, there's very little that you have to pick up. Existing support systems and community, we are looking at it. I don't even need to explain that point. And this would be a typical architecture that you should look at when you build an IoT pipeline, right? you have whatever your devices are here. You go into the AWS Cloud, you have a rules engine which basically splits up your topics. You have an Amazon Kinesis Firehose which is consuming data in real time. Anything that goes out of the rule can be fired through an SNS or a Lambda. Take that, process it, push it to your store, go into SQS, again go into Lambda, you can push it to whatever your store is, and then you pull your analytics on the other end. So S3 can be used either for storage or for displaying your analytics as a website, right? So this is sort of where you should get to when you fire up your IoT architecture discussion. What we're looking at is a pure play AWS model, but that said, Greengrass is dependent completely on your application, your use case, and so on. With that, my very quick presentation is done. I think I have about 5 minutes, so I'll take 2 or 3 questions. I didn't have that plan in mind, but yeah, if you've got questions, I can take them. If it's regarding a Zoomcar booking, I'm sorry, I'm not carrying my laptop.
I have a question for you. How bad would the driver score be for someone to not get a Zoomcar at all?
It would not be that bad because we have sane thresholds. I didn't set them. So
I might get a car.
You will. There is no might, you will get a car. The kind is something that is dependent on it, but again, that is a hypothesis that this is how we want to go. Right now, driver score is internally used for us to understand driver behavior. So if for example, on a scale of 1 to 5, 5 being the best driver, if a majority of my driver data is in the band of 1 to 3, then maybe my threshold is high, or maybe there are too many bad drivers in India. So we're trying to understand that as well. Yes, sir. We don't. They're off the roads now. The cycles are no longer live on the platform. We had something called Pedal. Pedal has been put on standby for a while because we're focusing more on the e-scooters right now. E-scooters are live only in Bangalore city as of now, but they will be going through a nationwide launch in the next quarter is what I hear. So all the major metros, they'll start off and then we'll start going into tier based on how the demand works. Pedal might come back, but I do not have an answer. Yes, sir.
Was there last 1 year before. I was there in that time. So I was wondering how do you manage that communication with that?
Same thing. So okay, so there's a bit in the IoT equation that I did not talk about because it's not an IoT conference. Each of the devices has something called an M2M SIM, machine to machine SIM. These SIMs do not require registration to a network. They're not Airtel SIMs, they're not Vodafone SIMs. As long as they have network coverage, they hook push data. There's a separate architecture diagram and a discussion that we can do, but probably not the stage for that topic. Someone behind you had a question. Yeah.
So I'm curious about the subscription thing you talked about from Zoomcar,
right?
The 18-month thing, and I'm curious about what kind of data, the breakage maintenance, the Obd2 Data. I'm just curious about it. Can you explain more about that?
Okay. Each car has all Zoomcar vehicles plug in through the OBD. Our IoT systems connect to the OBD, but there are additional connects as well, where we connect to the battery system, we connect to the engine monitoring system, we connect to the ECU. So the catch there is not all vendors allow it, because OBD is a protocol, but what data gets transacted on OBD is not a defined protocol, right? So for example, Hyundai encrypts it. Mahindra has no clue what it's doing. Maruti is like, data मिलेगा तो मैं तेरे को दे देगा, मेरे को मिल नहीं रहा है. So it's It's per vendor, per model, there's a difference. Like a Swift won't behave the same way a Bereza behaves for the same Maruti brand. Zapsubscribe.com. This is not where I do marketing for Zoomcar. I mean, this is enough marketing, nothing else. That's all I'll do.
So one here. So do you have any plans of productizing the driver recommendation as a platform?
I'm not at liberty to answer that question.
Okay.
There is IP involved, so I will not make a statement that may or may not be in line with my company. So.
Is there any ML model or AI model which is
There is a continuous set of ML models that run 24/7 unattended, and they just keep pushing data into the Redshift cluster that I spoke about. And then there's a data analytics team which pulls data from Redshift and converts it into a business readable graph of sorts.
so this driver benchmarking also
Driver score is also a machine learning model. So what it does is so you as a driver would have done, let's assume 10 Zoomcar bookings. I have 2 minutes. Let's assume you've done 10 Zoomcar bookings. I will now ask the model to pull up all my IoT data for every one of those 10 bookings and then run it through a mathematical model.
so this has the only the driver how it engages with the driving patterns or how it
Driving patterns is one of the major aspects of it. It's not the only aspect of it. So there's the other side where how did you come into the website? How did we capture you? What is my customer acquisition cost of having you on my platform? How many calls did you make to the customer care? How many lock attempts, unlock attempts did you have to do before that action actually succeeded? So each of these, like for example, all cars are keyless entry, right? So you press a button on the app, the car locks or unlocks. If you press it once and the car immediately unlocks, then I know you've had a good experience. But if you had to press it twice, then I have a factor by which I will reduce the experience quotient. All of this adds together. It's not just your driving behavior. And because the car didn't unlock on your third attempt, you're now frustrated, you're showing the frustration on the car. That's natural human tendency, right? And like, I need to hit someone, you can't hit your wife. Still a crime.
traffic patterns on the road will make
Which is also something that we capture. There's way too many metrics. That's why I leave it to the data team. You're like, you want servers, I'll give you. Would that be all? I'm here the whole day, so any other discussion we can happily have. Thank you so much.
So I'm obviously going to request another round of applause, but not now. I have to give you context as to why I am demanding that. We had a gentleman, Gaurav, who was supposed to come and address us from Hotstar, who's also an AWS community leader. And unfortunately, because of certain exigencies, they had to cancel. And really, really short notice, we had to go on the Zoomcar app and book Ashwin for this session. Thanks to the cloud and the technology that they have, he was able to make it. So I demand the highest of, loudest of applause for Ashwin, please. So can I have Sharika on stage to present the token of appreciation, please? Thank you so much.